going to look at inequalities, but we're going to look at a shorthand version of doing the notation for it. It's called interval notation. So while our objective is still I can solve and graph inequalities, most of these are going to be looking at it in a different type of notation and thinking and translating it back into the notation we're familiar with. So what we have is we're going to be using parentheses and brackets for this notation. Now we're used to using parentheses when graphing ordered pairs, x's and y's. Just so we know, that's not what we're doing here. This is just graphing x's on a number line. So when we're using just the parentheses, those are going to be greater than or less than. In other words, they're open notations. It's like using between notation using instead of parentheses. So for instance here, this is saying all the numbers between 8 and 10. So greater than 8 and less than 10. So they're between statements. So here, these are using the or equal to inequalities, and so they're going to be closed when we graph them. So let's take a look at this as an example. Let's just graph these inequalities that are in the shorthand version of interval notation. All this is it's like writing x is between 10 and 8, using that between notation. So I'm going to go out here, I'm going to have an 8 and a 10, and I'm going to put open dots on 8 and on 10, and graph everything, all the numbers in between those two. That's all interval notation does. That's a shorthand version. Notice it's shorter to write that than to write this. This, for instance, would be I'd have x between 6.5, and notice it's open on this side because of the parentheses, but on this side it's closed because of the bracket. So it's an or equal to. So this one we'd have back here at -1. We go out to 0, 1, 2, 3, 4, 5, 6. Out here's 6.5. And I'm going to put an open dot on that 6.5. And I'm going to put a closed dot on the 1. And I'm going to graph everything in between those two. So between notation this is just a shorthand way using interval notation to write the same inequalities. Now, what happens if we have this type of thing where we don't actually have it between two numbers, but instead just it goes on forever? This is just x is greater than 4. Well, we can use between notation if we use the concept of infinity and negative infinity. Infinity is something that it goes on forever in the positive direction. Negative infinity is something that goes on forever in the negative direction. So here we're going to have an open dot on 4, and then it's going to go off to infinity. Now we don't ever get to infinity, so when you do use the infinity in the interval notation, it should be with an open parentheses, not with a bracket, because you never actually get there. It can't be closed off. So for this one, we have an open side on 7, but then it goes to negative infinity, goes in the negative direction. So this interval notation says we're going to have it be from 7 over to negative infinity, and using an open, we need to close this one off because 7 is an or equal to, so it needs to be a closed bracket. But negative infinity, the infinities are always open parentheses because we never actually get there. All right, so a key concept now for some of our notation for this, we're going to use U for union and an upside down U for intersection. Those are, again, shorthand notations for talking about our ors and ands. This is an or, this is an and when doing the problems. So when I look at these two, what I'm looking for is the intersection of the two of them. So just a quick graph of these two. If I go from here, I go from -6 to 5, and I put an open dot here because of the open parentheses, and a closed dot here on the 5, this is what that graph would look like. This graph, on the other hand, starts at 3 with a closed dot and goes out to 7 with also closed dot. Now what I'm looking for is, where do those two graphs intersect? Notice that their overlap, or their intersection, is from 3 to 5. So what I have for my overlap here is that x is going to be between 5 and 3. That's the way to write it in our traditional notation. Our graph would be from 3 to 5, where you have closed dots on each and in between. And if we were to write this in interval notation, because it is between two numbers, we could write this with a bracket on 3, a bracket on 5, and that would be our final answer for that intersection. Let's try this one. This is a union, meaning we're going to put them together, all together. So this graph here, this first one, is going to be starting at 4, and it's going to go off to negative infinity with an open circle on it. This one, on the other hand, this number line, is going to be a closed dot on 0, and then it's going to go off to 9 out here, and at 9 it's going to be an open dot, and then everything in between that. Now here, if this were an upside down U, an intersection of these two, we would look at where these intersect. It would be between 0 and 4, with a closed dot on 0 and an open dot on 4. But this one is an or a union, so when we put them together, join the two together, notice we want anything that's covered on one graph is covered in our final solution. So I have to go all the way out here to 9. It goes here, but it goes past 0 because this one goes past 0. It just keeps going on forever when I put those two together. So the actual solution here is x is less than 9. And how we write that in interval notation is we write the 9 with an open parentheses there because it doesn't have a closed dot, it's an open dot. And then it goes off to negative infinity when it goes off to the left direction all the way. So interval notation is shorthand. When we're doing these inequalities, if we want to do these, we think about using parentheses or brackets to do our closed or open dots. We can use infinity and negative infinity, but make sure you use a parentheses on those if it goes off to infinity to the right or negative infinity to the left. And then we can do unions or intersection problems by joining them together for the union or finding the overlap or the intersection for the intersection problems or the and problems.